All right, we're going to jump into lesson 20.2, which is going to be on angle, side, angle, triangle congruency theorem. And so we'll just take a look at what this congruency theorem is. It says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent here. So this is just another congruency theorem. We've already seen a couple of these. It's just a different pattern here, a different combination of angles and sides. So it says two angles and the included side. Okay, and so that's going to be important here. So if we have some setup that looks like this, let's say it's these two angles. This angle is congruent to this angle, and we'll say this bottom right is congruent to this bottom right. And then it says the included side. So that means that the side in between here. So that would be this side down here and this side down here. So the side that's included in between the two congruent angles. Then we can say that these triangles as a whole are congruent by the angle, side, angle theorem. And that's ASA for angle, side, angle. Let's take a look at what this might look like. It says determine whether the triangles are congruent. Explain your reasoning. So a couple things we can do here. First, we see that we have some congruent sides, right? So we've got 2.3 is congruent to 2.3, right? So we've got a pair of congruent sides there. We also know that 61 is congruent to 61, right? So that we've got some congruent angles there. And then we know that this is angle 45 here. Angle A is equal to 45, but we don't know what angle D is, and that's the angle that we would need to prove this using angle, side, angle. But we can find what angle D is going to be, and we can do that by doing 180, because that's the total for this whole triangle, right? Minus 74 minus 61, and then that should leave me with whatever angle D is, right? Because I know that all three of these together equal 180, and in fact that does give me 45 degrees. And so this angle is 45, and so then I know that angle D is congruent to angle A, and now I can say that these are going to be congruent by angle, side, angle. So these are congruent by ASA. All right, and we'll keep moving here. We'll check out letter B here. So same idea. Let's check out what we know right now. We've got that angle, that this side PM, which is 62 inches, is congruent to side LJ, which is also 62. And we know that angle M is congruent to angle J because they're both 31. Okay, and then since we need this side to be in between the angles, that means that we would need P and L to be congruent. We don't know what P is, but we can find out what it is, right? Because we know that for this triangle here at the bottom, the total is 180 degrees. The interior sum is 180 degrees. And so I'm going to subtract 38 and subtract 31. That'll give me what angle P is going to be here, right? So some quick mental math. And we can see that we're going to be just off here, not quite 110. I think this turns into 111 degrees. And so then we know that angle L and angle P, angle L and angle P, these are not congruent to each other. So then these two triangles are not going to be congruent by angle, side, angle. All right, we'll keep it moving here down to letter C. Okay, for letter C, it's important to notice that we've got a right triangle here, right? We've got this triangle which is ADC, ADC, that's my right triangle. Okay, and then they've already given me some information here. They told me that angle B is congruent to angle C. They also told me that side BD is congruent to side CD. And then there's one more piece that we can infer here based on the setup that we have. I know that this is a line BDC, right? This is a line, which means that this whole line has to equal 180 degrees. Well, if this piece right here is 90, then I know that the other side also has to be 90, right? And if both of those angles are 90, then they're going to be congruent to each other, right? Because they're both 90, so they're both going to be congruent to each other. So I'm going to do double arcs here, try to zoom it in so it's nice and clear. Okay, so those two angles are going to be congruent to each other, and so then we can say, yes, these are going to be congruent by angle side angle. And once again, that's because we knew both of those were 90 degrees. All right, we keep going. We'll check out letter D here. So we'll check out the given information. We know that these two sides are equal. That's side TU and side QR, because those are both 1 inch. We also know that angle T is congruent to angle Q because they're both 38. Okay, and then for these to be congruent by angle side angle, we would need angle R to be congruent to angle U. That way we would have this included side, right, in between those angles. So we got to figure out what angle R is because we don't know that right now. So of course I'm just going to go back to this. I'm going to say, okay, well 180, that's the grand total, minus 38 minus 72. Okay, and again, some quick mental math here. That's going to give me 70 degrees. And so then that tells me that angle R is 70 degrees. Okay, and then that's not going to work for us, right? U and R are not equal, right? Because angle U over here is 67 degrees, and so these are not going to be congruent by angle side angle. All right, we keep going here to our proofs. We'll go through a couple proofs here. I know sometimes these are a little bit tedious, but we'll try to get through these together here. It says write a proof, and then I've already written out the given information. So remember, your first step should always be what they give you. So you can take a second, pause this, and write down the given information here. We're going to use a 2-column proof. Okay, and so we're starting here, writing down what they gave me. They told me that angle MQP is congruent to angle NPQ, so I put that. Okay, and then they told me that angle MPQ is congruent to angle NQP, and so I've marked that as well. And then it's always super helpful to mark this on our image. So whatever they told me, I want to mark that on my image so I can kind of visualize things a little bit better. Notice the 2 triangles that we have here, right? We have like kind of the top half here, that's one triangle, and then we have the bottom half here, that's the other triangle. So let's see what they told me. They started by telling me that MQP, so MQP, that's this angle right here, okay, is congruent to NPQ, which is going to be this angle right here. So we know those 2 angles are congruent. Okay, then they also told me that angle MPQ, that's right here, is congruent to NQP, which is right here. Okay, and then notice we've got 2 angles, 2 pairs of angles that are congruent. We need the included side, so the side in between these, to be congruent to use our angle side angle, right? Because the side has to be in between. So that means that we would need this side in between the 2 congruent angles, right? The 2 congruent angles are right there. So we need this side in between to be congruent. And we know that's going to be true because for both triangles, that's the same line. So I'm going to go ahead and say, okay, well, that's line QP, or in this case, I guess it's a segment, right? Side QP is congruent to side QP, right? That's obvious, but we have to state it. And remember, that's the reflexive property of congruence. So I'm going to say reflexive property of congruence. I'm going to say POC for property of congruence. All right, and so then we know that these triangles are congruent because we have this angle side angle setup, right? We have an angle, a side, and an angle, and then down below we have an angle, the side, and an angle, and so we know these 2 are congruent here. So I'm just going to make that final congruency statement, which is triangle MQP is congruent to triangle NPQ, and that's by angle, side, angle. All right, there's one. Let's move to the next one here. Once again, I've already written down the given information, so you should go ahead and pause this and write that down so you're caught up with me here. And I'm going to start by marking this on our triangle. So first they told me angle A is congruent to angle C. So that's angle A here is congruent to angle C here. And then they told me that E is the midpoint of AC. So E right here in the middle is the midpoint of AC. So AC is this line, right? Okay, and so it includes those two sides there. So if E is the midpoint of AC, then I must know that from A to E has got to be congruent from C to E, right? Because it told me that E is in the middle there. Okay, so I'm going to make that statement here, and that was that AE is congruent to CE. And we knew that because E was the midpoint, so I'm going to put definition of midpoint. Okay, and so we're getting closer here. So we've got an angle and we've got a side, right? And on the other triangle, same thing, angle and a side. And remember, if we want to use angle, side, angle, then we need one more angle. And we want the side to be in between, so we need this angle here, right, to be congruent. And we know that's going to be true. I'll give you a second to think about how we might know that those angles are going to be congruent to each other. And hopefully you're coming up with, remember, when we have a setup like this, kind of this bow tie setup, we usually end up with vertical angles. So that means that we've got this angle here is congruent to this angle here because those are congruent angles. So now I'm just going to name those in my proof. So we've got angle AEB is congruent to angle CED. And that's because that's a vertical angle. So I'm just going to put vertical angles. You could add vertical angles are congruent. Okay, and so then we have this setup, which is what we need. We've got an angle, a side, and an angle, right? And on the other triangle, angle, side, and an angle. Okay, so we can use this ASA triangle congruency theorem. So I'm going to just state my final congruency statement, which is that triangle AEB is congruent to triangle CED, and that's by angle, side, angle. Okay, and we'll go to one last proof here. For this one, I didn't write down the given information yet, so we can write that down together here. So first, we've got angle JLM is congruent to angle KML. And I'm going to mark those on my graph here, on my image here. So notice we've got two triangles here, right? JML, which is like kind of this triangle here, okay, on the left side. And then we've got a triangle KLM, which is this triangle here. And they overlap, right? So it's like two triangles overlapping here. So as I mark these, just pay attention to that. So first JLM, that's this angle down here, is congruent to KML. That's this angle over here. And then it tells me that angle JML, I'm looking at the given information here, is congruent to angle KLM. Okay. So that's JML. Okay, so this is going to get a little tricky. So that's like this little angle here is congruent to KLM. That's going to be that angle there. And so what I'm actually going to do is I'm going to kind of separate this image so you can see it a little bit more clearly on what these two triangles are, right? So right now we kind of have one triangle that looks like this, right? That's the one that's on the left. And then we have another triangle that looks like this. That's the triangle that's on the right. And then what they've done is kind of just like slid these things on top of each other, okay, so that they kind of slid together. But basically the setup that we have right now is that this angle here at the bottom is congruent to this angle here, and then these interiors, these smaller angles, are also congruent, okay? And then the last, and these are both given information. And so we've got two angles, right? Angle, 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 angle. We need the included side to be congruent for these triangles to be congruent, and we know that's going to be the case because if you look back at our image here, this included side, well, that's the side on the bottom, right? Which is the same for both of them. Okay, so these are going to be congruent, and we know that because these are the same exact side, right? So the same length, they're congruent to each other. And remember, that's from the reflexive property of congruence. So LM is congruent to side LM, and that's the reflexive property of congruence. And so then we can say these triangles are congruent by ASA. So triangle JML is congruent to triangle KLM, and that's by angle, side, angle. All right, thanks for watching.